Okay, let's talk about exponential distribution. Uh, exponential distribution. Uh, in exponential distribution, we will deal with the continuous random variable. uh, क्योंकि एक्सपोनेंशियल जो फंक्शन है दैट इज़ अ कंटिन्यूस है, इसलिए हम जो रैंडम वेरिएबल एक्स है उसको कंटिन्यूस कंसीडर करेंगे. A random variable x is called exponential random variable. ये जो x रैंडम वेरिएबल है इसको हम एक्सपोनेंशियल रैंडम वेरिएबल कहेंगे with parameter lambda which is greater than 0. और इसका जो PDF है its PDF as f of x lambda into e raised to power minus lambda x when x is greater than 0. So when x is greater than 0 तो इसका जो PDF है दैट इज़ लैम्डा इंटू ई रेज पावर माइनस लैम्डा एक्स, जबकि ये जो लैम्डा पैरामीटर है दैट इज़ ग्रेटर देन 0. अदरवाइज जो है when x is less than 0 toward the negative side it would be 0. इसका एम्पलीट्यूड 0 होगा toward the negative x axis. Therefore हम इसे कहते हैं यूनिलैटरल फंक्शन भी कहते हैं. एंड यू गाइज आर फेमिलियर विद द यूनिलैटरल एंड बायलैटरल फंक्शन इन द लैप्लास ट्रांसफॉर्म. सो हम इसको जो है यहाँ पे डिस्कस नहीं करेंगे यूनिलैटरल और बायलैटरल फंक्शन को. फर्दर जो इसका मीन है एक्सपोनेंशियल डिस्ट्रीब्यूशन का दैट इज़ the mean of exponential random variable x as mean को हम म्यू से रिप्रेजेंट करते हैं. म्यू ऑफ एक्स to e of x is equal to 1 over lambda. So जो इसका मीन है वो 1 ओवर लैम्डा के इक्वल है. फर्दर इट्स वेरिएंस इज सिग्मा स्क्वायर दैट इज इक्वल टू 1 ओवर लैम्डा स्क्वायर. फर्दर this it is the PDF of exponential random variable. So in order to find the CDF of exponential random variable तो हम क्या करेंगे, the CDF of exponential distributive function as हम इंटीग्रेट करेंगे PDF को फ्रॉम 0 to x. सो CDF को कैपिटल F से f of x आई विल इंटीग्रेट इट फ्रॉम 0 to x. जब 0 to x इसको इंटीग्रेट करेंगे लैम्डा इंटू ई रेज़्ड पावर माइनस लैम्डा एक्स d of x. So I will get it e raised to power माइनस लैम्डा एक्स और 0 to x तक इसको इंटीग्रेट करेंगे. सो इवेंचुअली ओके नेगेटिव साइन भी साथ आएगा आफ्टर इंटीग्रेशन. आई विल गेट it as minus e raised to power minus lambda x minus e raised to power 0 would be equal to 1. So the CDF would be equal to 1 minus e raised to power minus lambda x. अगर हम इसके PDF को प्लॉट करें, that is f of x. So इस फंक्शन को अगर हम प्लॉट करें, this would be equal to when x is equal to 0, it would be equal to lambda. As we increase the value of x, तो ये decaying function होगा because the power of the exponential function is negative. So इसका CDF इस तरह से होगा. मैक्सिमम वैल्यू लैम्डा है, लैम्डा इंटू ई रेज़्ड टू पावर माइनस लैम्डा एक्स. और जो PDF होगा, अगर इसको प्लॉट करें, when x is equal to 0, 1 minus 1, so this e raised to power minus 0 would be equal to 1. It's अगर हम PDF को प्लॉट करें तो when x is equal to 0, e raised to power minus 0 is equal to 1. So we will get here 0. So by increasing the by increasing the value of x, so ये जो फंक्शन है CDF, it will start increasing. Eventually we will get this value approaches to 1. This is the plot for 1 minus e raised to power minus lambda x. Now let's solve some examples that are related to exponential distribution. Assume that I'm taking this example from your book. Assume that the length of this is example that the length of a phone call in minutes is an exponential random variable x with parameter lambda is equal to 1 over 10. If someone arrive at phone booth just before you arrive, find the probability that you will have to wait first part is less than 5 minutes, the second part is between 5 and 10 minutes. Now we have assumed the length of phone call in minutes is an exponential random variable x with parameter, its parameter lambda is equal to 1 over 10. If someone arrive at booth just before you arrive, आपके आने से पहले जो है कोई अगर पहुंच गया बूथ पे, find the probability that you have to wait, that you will wait less than 5 minutes, between 5 and 10 minutes. So in first case we have to find that you have to wait less than 5 minutes. So in first case, first we have to write the PDF of random variable x would be probability distribution function of x is, we already know f of x is equal to 1 over 10, that is lambda. अगर हम इस फार्मूले में इनकॉर्पोरेट करें, lambda is 1 over 10 and e raised to power minus 1 over 10 x when x is greater than 0 and 0 otherwise when x is less than 0. So its probability or its CDF would be P of x is less than 5. तो हम क्या करेंगे, इंटीग्रेट करेंगे फ्रॉम 0 to 5 मिनट्स तक. PDF को 1 over 10 e raised to power minus 1 over 10 into x d of x. So after integration I will get e raised to power minus e raised to power minus 1 over 10 into x, और इसके लिमिट्स हैं फ्रॉम 0 to 5. So e raised to power minus 5 by 10, when we put limit 0, so e raised to power 0 would be equal to 1. So I will get 1 minus e raised to power 0.5. And this is equal to, okay, after solving this, I will get the answer would be 0.393. So what would be the probability that you will have to wait less than 5 minutes? That is almost 39%. So the next question is, you have to wait between 5 and 10 minutes. So in B part, random variable x is greater than 5 less than 10. So we will integrate from 5 to 10, 1 over 10 e raised to power. तो इसके अंदर हम, इस लिमिट के अंदर हम क्या करेंगे, PDF की वैल्यू को इनकॉर्पोरेट करेंगे, माइनस एक्स डिवाइड बाई 10 इंटू डी ऑफ एक्स. तो इसको जब हम इंटीग्रेट करेंगे तो आई विल गेट e raised to power minus 0.5 माइनस e raised to power minus 1. तो इसको जब सॉल्व करेंगे तो प्रोबेबिलिटी आएगी 0.239, ऑलमोस्ट 24% जो है इसकी प्रोबेबिलिटी है दैट यू हैव टू वेट बिटवीन 5 to 10 minutes. Okay, move to next example. Another example is all manufactured devices and machines. This is from your example. This example is from your book. all manufactured devices and machines fail to work sooner or later. You have to suppose that the failure rate is constant and time to failure is an exponential random variable. Is an exponential random variable x with parameter lambda. So all manufactured devices and machine fail to work sooner or later. Suppose that the failure rate is constant and the time to failure, that is in hours, is an exponential random variable with parameter lambda. Uh, in first part, uh, measurement shows that the probability measurement shows that the probability that the time to failure for computer memory chip in a given class exceeds 10 raised to power 4 hours is e raised to power minus 1, and e raised to power minus 1 is approximately equal to 0.368. Calculate the value of parameter lambda. The value of so we have to calculate the value of lambda. The measurement show that the probability that the time to failure for computer memory chip in given class exceed 10 raised to power 4 hours. So we have to calculate the value of lambda. So we already know that the PDF is equal to 1 minus e raised to power minus lambda x when x is greater than 0, 0, otherwise when x is less than 0. So when x is greater than 10 raised to power 4 hours, this is equal to 1 minus, इसका कंप्लीमेंट हम ले लेंगे, प्रोबेबिलिटी x इज लेस देन और इक्वल टू 10 raised to power 4, या हम लिख सकते हैं 1 minus f of x 10 raised to power 4. सो 1 माइनस इस प्रोबेबिलिटी सॉरी CDF की वैल्यू जब हम इनकॉर्पोरेट करेंगे तो दिस इज इक्वल टू दिस. So 1 minus e raised to power minus lambda or x is equal to 10 raised to power 4. So this would be equal to e raised to power minus lambda 10 raised to power 4. और ये किसके इक्वल होना चाहिए? e raised to power minus 1. This should be equal to e raised to power minus 1. So by comparing these two sides, we will get lambda is equal to 10 raised to power minus 4. और इसी क्वेश्चन का बी पार्ट है. नाउ इन बी पार्ट using the value of parameter lambda, determine that we have find in part A, determine in part A, calculate the x naught such that probability that the time to failure is less than x naught is 0.05. So again the CDF would be f of x naught that is equal to x is less than or equal to x naught. और ये किसके इक्वल होगा? यूजिंग द वैल्यू ऑफ parameter lambda, determine in part B, calculate that the x naught such that the probability that the time failure is less than x naught is 0.05. So ये probability होनी चाहिए that is equal to 0.05. यहाँ incorporate करेंगे. Now this CDF is equal to 1 minus e raised to power minus lambda x naught is equal to 0.05. So this would be equal to 1 minus 0.05 और इसको हम मूव करेंगे इस एक्सप्रेशन को राइट साइड पे e raised to power minus lambda into x naught. So e raised to power minus lambda x naught is equal to 0.95. Taking the log on both sides, so दोनों साइडों पे log को अप्लाई करेंगे because we have to find x naught. So minus lambda x naught is equal to log of 0.095. और लैम्डा की वैल्यू ऑलरेडी हमें मालूम है दैट इज इक्वल टू 10 raised to power minus 4 and x naught is equal to minus 10 raised to power 4 log of 0.95. इसको सॉल्व करेंगे तो वी विल गेट x naught is equal to 513 hours. ओके इक्वल है. Now the next example is power supply a power supply unit of computer component is assumed to follow exponential distribution with mean is 1200 hours. And what is the probability? We have to find the probability. What is the probability that component will, first we have to find fail in, the component will fail in first 300 hours. In B part we have to find the component will survive more than 1500 hours. So in first case we have given the mean in this case that is equal to 1200 hours. So the mu, let's solve the first problem here. The mu is 1200 and lambda would be 1 over 1200. So it's CDF, so the fail in first 300 hours, so we have to find P of x. So x is less than or equal to this, suppose in hours I am considering it k. So this k or x, small x, is equal to 1 minus e raised to power minus lambda into x. So we have, in first case we have to find the probability that component will fail in first 300 hours. So P of x less than or equal to 300 is equal to 1 minus e raised to power lambda is equal to 1 over 1200 minus 1 over 1200 and x is equal to 300. So I will get this P of x is less than or equal to 300, that is equal to 1 minus e raised to power minus 300 divided by 1200. This is equal to 1 minus e raised to power minus 0.25. So after solving this I will get 1 minus, this is equal to 0.7788. So this will be equal to 0.2212. So the probability of the component or the device that will fail in first 300 hours is almost 22%, that is 0.22. So in second part we have to find that the component will survive more than 1500 hours. So in this case probability of x is greater than 1500. So this is equal to 1 minus f of x, f of 1500 सो इसको जब हम सॉल्व करेंगे तो 1 माइनस ई रेज़ टू पावर लैम्डा की वैल्यू 1200 है, माइनस 1/1500 डिवाइडेड बाय 1200. So this would be equal to e raised to power minus 1.25. So after solving this, we will get approximately answer is equal to 0.2865. So almost 28% chances are the probabilities that the component will survive more than 1500 hours. So that's it.